Good morning, and thank you very much for joining us today. I'm Jeffrey Smith with Honda, North American Corporate Communications. Our two companies have some very exciting and truly historic news to share with you today. It's all about the future. But first, I would like to recognize our speakers and some of the other individuals you might want to know in relation to this announcement. Please hold your applause until I get to the end. First, we have as our guest the Honorable Brian Calley, Lieutenant Governor of the state of Michigan. We sincerely appreciate how you're joining us today, sir. We understand that Governor Snyder is out of the country, so that makes you the state's acting chief executive. So for today, Governor, welcome. From General Motors, joining us is Mark Royce, Executive Vice President, Global Product Development, Purchasing, and Supply Chain. Maybe raise your hand so I know no one knows who you are, Mr. Royce. Alicia Bowler-Davis, Executive Vice President, Global Manufacturing. Dan Nicholson, Vice President, Global Propulsion Systems. Thank you. And Charlie Fries, Executive Director, Global Fuel Cell Business. And from Honda, joining us is Toshiaki Mikoshiba, President and CEO of American Honda Motor Company and Honda North America, and Chief Operating Officer of the North American region for Honda Motor Company. Takashi Moriya, Senior Chief Engineer of Honda Research and Development. Rick Shostak, Executive Vice President, Honda North America. Stephen Center, Vice President of the Environmental Business Development Office and Product Regulatory Office of American Honda Motor Company. So thank you. It's kind of like the bride side and the groom side here. Now I have some quick housekeeping details. In a few moments, two of our respective companies' top executives will share the news with you. And then we'll hear from Michigan's Lieutenant Governor. And then we'll share what's under this cover here. We have a very brief photo session immediately following that. And then our executives and a few experts will conduct a Q&A so you can fully understand today's announcement. You should know that this newscast is being live streamed and will be recorded and available to you afterwards, and that images will be available on our respective news sites immediately following the news conference. Also following this news conference, we will have a teleconference. That's a Q&A for those who could not join us in person this morning. And for any of you who want to listen, please contact the GM PR staff or the Honda PR staff, and they'll give you that number if you do want to call in. So to get things started, let me ask Mikoshiba-san to come up here and share some of today's news. Mikoshiba-san.
Thank you, Jeffrey. And good morning, Lieutenant Governor Calley and everyone. We are pleased to be in Detroit today to announce the latest step in our equal partnership with General Motors. Over the past 3 years, engineers from Honda and GM have been working as one team, with each company providing know-how from its unique expertise to create a compact and low-cost next-generation fuel cell system. This foundation of our outstanding teamwork will now take us to the stage of joint mass production of a fuel cell system that will help each company create new value for our customers in fuel cell vehicles of the future. Today, we are pleased to announce that Honda and GM are establishing a new joint venture company, Fuel Cell System Manufacturing, that will produce a next-generation fuel cell system here in Michigan. Based on our co-development, this new generation stack builds on the compact size and high performance of Honda's current generation stack by achieving significant cost reduction. It will be applied to distinct products from each of our companies. Honda has always been open to strategic partnerships that benefit our customers and society. The successful sharing of engineering expertise has led to this new joint venture between Honda and GM to do just that. The new joint venture will be operated by a board of directors consisting of 3 executives from each company. A president and executive vice president will be appointed from the respective partners to rotate between each company every 2 years. Based on Honda's approach to build products close to our customers. We have nearly 40 years of manufacturing history in America, with 12 US plants. As a result, the vast majority of the cars and trucks we sell here are built in America. We also wanted this new fuel cell system to be built in the United States. At this stage in the advancement of the technology, it is more efficient to have one operation building the fuel cell system for unique vehicles to be offered by each company. Last month, Honda began delivery of our third generation fuel cell vehicle in the United States, the all-new Clarity fuel cell. This year, we also will debut the Clarity Electric and the Clarity plug-in hybrid to be sold in all 50 states. So, the future Honda vehicle that will be powered by the new co-developed system will be Honda's fourth generation fuel cell vehicle. We have established a challenging goal to make 2/3 of our global sales from electrified vehicles by around 2030. Hydrogen fuel cell vehicles are part of this plan because, in our view, they represent the ultimate mobility solution with no compromise required from our customers. The driving performance and refueling experience are similar to a traditional gasoline vehicle. In addition to our joint efforts to build an advanced fuel cell system in Michigan, GM and Honda will continue to work together to further advance refueling infrastructure. This remains a critical step in the long-term viability and consumer acceptance of hydrogen fuel cell vehicles. Honda believes that hydrogen fuel cell vehicles can act as a core energy system to support a sustainable society and meet the needs of our customers. This shared commitment between Honda and GM is the foundation of new joint venture company. Now I would like to invite Dan Nicholson to make a few remarks. Thank you.
Thank you, Mikoshiba-san. And good morning, everyone. We appreciate you being here. GM and Honda have been working on fuel cell technology for an awfully long time. Our program is rooted in the Apollo space program of the 1960s, when we developed the world's first hydrogen fuel cell vehicle, the GM Electrovan. The technology has come a long way in 50 years, and the cost has come down dramatically because of efficiency and the reduction in precious metals needed. GM and Honda have both had fleets of fuel cell vehicles that accumulated millions of miles of real-world experience driven by real customers in everyday driving situations. This all helped establish the starting point for something bigger. In July 2013, Honda and GM signed an agreement to work together on next-generation fuel cells and hydrogen storage systems. At the time, it was reported as a pretty big deal, and rightly so. Two leaders in fuel cell patents and technology working together as one company with shared intellectual property and integrated development teams. Since that announcement, we've accomplished a lot together, and many intercontinental flight miles have been earned. With Honda's liaison office in Pontiac, experts at both companies work together as one team in different time zones and locations to get us to where we are, our news today. Though there will continue to be skeptics, I think we can safely say that today's announcement officially marks the arrival of fuel cells. They're not a science project anymore. They're a mainstream alternative energy choice. Our common next-generation fuel cell system is smaller and lighter, more reliable, more durable, and more refined. And it is much less complex than what came before it. By the start of the new decade, we will be mass producing fuel cell systems in the same location as the GM battery pack manufacturing plant in Brownstown, Michigan. The systems assembled there will eventually lead to nearly 100 new jobs. The flexible, scalable production will allow Honda and GM to use the output for their desired needs and to sell to others. At this point, I want to especially thank Governor Rick Snyder, represented here today by Lieutenant Governor Brian Calley, and the Michigan Strategic Fund, which approved $2 million in incentives to help support the project. These are the kind of jobs that will contribute to making Michigan a leader in future mobility. Mikoshiba-san has already told you how the joint venture will be structured and will be governed. This truly is a one-company approach. Everything we have learned to advance the state of fuel cell manufacturing has been shared. The knowledge, the technological advancement, and of course, the intellectual property created. We are very excited for this partnership, and we look forward to helping move fuel cell propulsion to the mainstream. Thank you very much. And now I would like to invite Lieutenant Governor Calley to make a few remarks.
The advancement of technology in the mobility industry is truly breathtaking. And partnerships like this, it wasn't too long ago when it didn't seem very realistic. And while technology sometimes moves faster than the ability to bring that technology to market because of issues with respect to risk and bringing up the product to scale, a strategic partnership such as what is being announced here today makes it a reality. And out of it comes all kinds of opportunity for doing away with this old choice between the economy and the environment. This is one where the advancement and the partnership is great for our economy, and it's also, over the long term, great for our environment as well. And so we're very proud to partner, the state of Michigan is very proud to partner in this endeavor. And we are so thankful to Honda and to General Motors for making Brownstown the home of this joint venture, and we'll look forward to working with you in the future on ensuring that the cluster of activity, the brain power that is assembled in this region of our country and our world remains the epicenter in the future of the mobility industry. Thank you so much.
This is why it's all about the future. Introducing the General Motors Honda Next Generation Fuel Cell Stack. All right. Good. All right. Good shot. Smile. Okay. Lieutenant Governor, thank you, sir. Thank you, sir. Very good.
Thank you.
Thank you very much. Joining Mr. Mikoshiba, Mr. Royce, is Charlie Freeze. Charlie, if you wouldn't mind coming up. And Takashi Moriya, Mr. Mikoshiba. Both of these gentlemen were at our original fuel cell collaboration announcement in 2013. And both are deeply involved in this new joint enterprise. So, one note, please. Ron, 1 second. To our friends in the media, we understand that there are a great number of activities going on in and around our industry. But I will ask you to please focus your questions today on today's news. Now, if there are other matters you would like to discuss, we will engage on that. We will answer your questions, but we will do it separately. You'll have an opportunity to ask questions of our executives on an individual basis once we conclude this joint Q&A on today's news. Duran, you had a question.
Yes, Mark. General Motors Motors is more or less acknowledging that it plans to offer a commercial fuel cell vehicle. Can you please tell us more about that?
As I said, I guess that question comes to me, but it's right to Mr. Royce, so that's okay.
Okay. Yeah, we have not announced any retail fuel cell vehicle plans, and I would encourage you to think outside of the auto industry as well, because the fuel cell can be used in many different applications, including aerospace, military, all those type of things. So you're immediately zooming in on a retail application of this, which may or may not be the case for us, but we're not ready to announce that right now.
Thank you.
Sure.
Can you give us an idea of what sort of production scale you expect to have at Brownstown? What sort of volumes you expect to have in 2020?
Well, Mr. Charlie, would you want to take that one?
So
Thank you.
what we're doing here is we're trying to set up in a way that we can scale the capacity of the manufacturing facility to meet the demand in the marketplace. So we obviously don't invest all of that up front. We do it in a period of modules that we can go through iteratively and scale up to meet requirements. So we don't announce at this point the specific volumes because I think it's still too far out to give those kinds of commitments. We have to watch and see how the market develops at this point. But we'll be able to scale up to very high volume if we need to through this facility.
Thank you. Paul?
Can you talk about the issue of the infrastructure, what it's going to take to actually support mass marketing, whether it, as Mark says, is automotive, military, or otherwise?
You know,
How do you get there?
yeah, that's a good question. I think we've got Steve Center here with our Environmental Business Development Office. Steve, you want to take a shot at that one? Do you have a mic for Steve?
Thank you.
It's coming right up.
Thank you. We're in the automobile business. We're living with an infrastructure that's probably 120 or 140 years old in terms of petroleum. So you have to plan ahead. And what we're doing in California is there's a commitment between the state and between private enterprise to build out that infrastructure. So what you're going to see is a ratcheting up. You need to have the infrastructure at a comfortable level so that people will feel comfortable with the cars. We need to have the cars in the marketplace so that it feeds the infrastructure. So in the case of California, the state has committed to make investments with the business community, and they have a plan for 100 fueling stations by 2020. Today, 30 are operational in Southern California and the Bay Area.
May I follow on that real quickly?
Sure.
What does it take to take this to a national level? It's all well and good to say you can buy this car and operate it just in California. It's a big state, but people generally buy vehicles for whatever they hope to do, driving to New York, driving to the Midwest. Can we really have a real market for hydrogen without having a national, not just a regional infrastructure?
Yes, definitely. And it's going to take planning and investment in the long term. I think what you're going to see is this type of marketplace developing in cities. The cities will grow to the suburbs will connect, and you'll see that kind of a footprint for hydrogen fueling.
Thank you, Steve. Sir.
Can I speak Japanese? Because my question is to
Mr. Mikoshiba? Okay. Would prefer Endo-san? We would prefer it in English if you can do
My
it.
question is, one is very simple. Why you choose to pick up the place of the production of the XCB system in the United States, not Japan? That's my first question.
Say that again.
なぜ日本を選んだんですか？アメリカを選んだの？ Why you pick up the U.S. for the production place?
Well, we have been working with GM for past 3 years, and we chose the United States, Michigan, to be the place to have a joint venture to mass produce our next generation fuel cell, because mainly because America is the world's largest market of fuel cell. So that's why we came to this conclusion to build our joint venture company in Michigan, United States.
Sir.
Yes, for the gentleman from Honda, could you quantify or give any kind of indication of the magnitude of savings this sort of joint venture will create for fuel cell vehicles? How much more viable as a commercial product will this be? Are you cutting the cost in half?
Let me ask the question of cost to both Charlie Freeze and Mr. Maria. So we'll both take a shot at that question, okay? Charlie?
So fuel cells are low volume right now, and that's not a surprise to anybody in the room. And part of making them lower cost is a combination of a few different things. First of all, sharing the investment to develop the technology helps spread the cost between two partners using exactly the same system. So we can make one design, tool it once, and it will apply to two different customers, the two parents of the joint venture. The other thing that we can do is go through design iterations rapidly, because it's all about designing the cost reductions into the system. And that's the process that we're doing jointly by applying the capability of both companies and doing things like reducing the amount of precious metal, integrating the system, taking parts out. Those are all elements of making the system less costly from the standpoint of manufacturing. And working tightly together between a manufacturing team and an engineering team, where it's really one team. There are no silos, there are no functional divisions. The complete purchasing, manufacturing, engineering all work together. And that way we can really design not just the processes to make the system and procure the system through the supply base, but the design as well. So those are all things that we're doing. And then the next piece is when you scale, having one design that both companies use means that we can increase the volume and bring scale economies into play much more quickly than we could do as individual companies in the space. So Maria-san.
Yeah. And the additional that it in, of course, that the both companies of the fuel cell areas technology leaders. So in that case, in a joint working, the one team that they're very good in the collaboration for the technical issue. So that is a precious metal case, and then not only the precious metal, they are changing the material, that is special material, from special material to the conventional material, and then that the integration in the component. So we just collaborate. They're using that both companies' technologies acknowledge that is very important for the very good in one team activities. Of course, that is in the future. That is the mass, both companies mass, and it's also very important. Of course, at first that is the making that is the one team, one stack, and one fuel cell system. That is we are concentrated to reduce the cost.
Can I follow up and ask what kind of volumes do you expect for the Clarity in the first year in 2020 compared to
The Clarity, your question is about the Clarity, or?
Well, about fuel cells.
We are not disclosing volumes at this point, right? Sir.
Manufacturing question for you. Can you tell me, is the fuel cell stack made by hand, or is there some sort of automated manufacturing way to put it together? And Charlie, can you give us a little idea of what the power output might be for that?
So we're not going to announce a lot of, Richard, we'll keep some of the technical details for a point in the future, but what I can tell you is that this is not just a hand-built stack. There's automation that goes into it, because the only way you can really do what we talked about scaling up and doing it in modules where we can increase capacity to follow demand means that we have to be able to automate this. And that's part of the collaboration, right? It's not just about making a design. It's about making a design that can truly follow the process of the manufacturing and build in the knowledge of how to make it as well as how to design it. And that's part of what we're doing.
Power output, can you give us some guidance there?
We're not announcing that today.
Okay, right, sir.
One quick housekeeping question. $85 million is the total investment.
Correct.
To equally share that.
Yes, that's correct.
Okay. And there were comments about the price had come down quite a bit, size, practicality. Does that mean that by the time 2020 rolls around, this would be a competitive price to an internal combustion engine?
Charlie, what do you think?
So in 2020, I think that you'll still have a higher cost system than what you have with an internal combustion engine. And I don't think that should surprise anyone, because you're comparing it to a propulsion system that's built in millions versus something that's going to be built in a relatively much smaller number. But we do think that the building blocks are in place to start to close that gap. And the technology that we're introducing here today is in many ways taking out huge portions of the cost basis that have gone in the historical fuel cell designs that have been released or talked about in the past. Things like precious metal levels coming down to where it basically takes that out as a major cost driver. And that always in the past has been one of the key things that's added a lot of cost to the system. And so I think we're not going to talk specifically about the cost here, and I don't want anybody to walk out thinking it's going to be exactly on par with an internal combustion engine in that time frame, because it won't. But we are taking a lot of cost out to make the system much more affordable, and it does things that no other propulsion system is capable of doing. So sometimes that cost basis that might be there might be well warranted.
And the fact that it's been mass produced is a major factor in that. The more fuel cells we make, the more popularized these are, the more we can bring the cost down. Lindsay.
Does the co-development end at the stack, or are you, both companies, collaborating on fuel system storage as well?
Charlie, again, I think maybe Maria-san also would have a comment on that.
Yeah, of course, we just in collaboration with the storage tank and the system, but that is in different of the, of course, the development technologies of both companies. But in this joint venture is not concentrated to the fuel cell system. Tank is the suppliers come based on our collaboration technologies. That is the system collaboration type of the different of the storage tank and the fuel cell system.
So just to clarify, both companies are working with their suppliers kind of separately on pressure tanks and storage.
Well, Lindsay, I'd have to just clarify that. So the way we're working together from a development standpoint is we work together on hydrogen storage as well as the fuel cell system. The fuel cell system is more than just the stack, it's the balance of plant around it that also makes the stack function. That's all part of the collaboration between the two partners. The partners are working together on hydrogen storage as well. However, just to be clear, the tanks are usually in some ways modified slightly to fit different vehicle applications. And so even if we use the same basic design architecture, it wouldn't necessarily be the same tank. And that is something that's usually sourced from the supply base. So I think just to kind of put it in context there.
Any more? We have time for one more, I think, sir.
Charlie, last year at the opening of the expansion of the Propulsion engineering facility in Pontiac, you talked about targeting 7 grams of platinum for the stack in 2020. Are you still on that target? Are you achieving that, or have you surpassed that? Or?
So today we're not talking specifically about the platinum level in the stack, although it's come dramatically. We've reduced it orders of magnitude from what has been used in the past. And that is why we are able to talk about the fact that the cost has come down quite dramatically in this iteration of the design. We do run systems in the laboratory today at around 7 grams, to your question. And that is the future that we keep heading for, is continuing to take platinum out of the stack and bring the cost of the system down. Yes.
Let me ask Mr. Royce and Mr. Mikoshiba a fundamental question. Sorry to surprise you with this. Why did GM and Honda decide to work together? Mr. Royce?
Well, I think it goes back quite a few years that Honda has been a very good partner with General Motors and General Motors with Honda, but also I think the level of respect and the relationships between our technical teams is extraordinary. Going myself personally all the way back to the first thing I took apart was actually a QA50, which was a Honda, and in a garage, and so the sophistication of propulsion and engineering in Honda is very, very high. So naturally, our technical teams are very, very, very good at working together. So that's what makes it very special for us. And Honda is a wonderful company with wonderful products. So we're very, very complimentary in that way.
Thank you. Mikoshiba-san?
Yeah, thank you for your comment, Mr. Royce. In addition to what you said, actually our relationship already began in 1999. Started from our V6 engine provided to GM. So total 50,000 units. So we already have a long-standing history behind us, and now today we are here to make a joint venture. So that's how we came to today's position.
Thank you, sir. That concludes our formal news conference. We'll be happy to take a few of your questions individually for a few minutes. Thank you very much.
Thank you.
Thank you.